Hello and welcome to the C programming lecture on Goto and labels. The Goto statement and labels are a way to provide a unconditional jump. So meaning you can use a label in conjunction with the Goto statement in order to go between blocks of code or go back up to blocks of code. So again, an unconditional jump can be thought of as either skipping a block of code or going up or down a various blocks of code. Typically, Goto statements are paired with label statements. And a label is really nothing more than just a name followed by a colon. So here's an example of some labels with some Goto statements. So what we can see in line 5 of our program is we are declaring a variable x. That variable is assigned the value 10. We then have a Goto statement which goes to a label named label2, and you can see on line 11 that that label is defined on line 11, and it actually skips over that and it prints out our variable. Then if x is equal to 10, it goes back up to label 1 and then reassigns the x value to 15 and then prints out 15. So that's how we get this weird ordering of jumping up and jumping down using Goto and labels. You can see the output on the right, which we have, it's 10 and 15. So again, breaking down the Goto label, we start by initializing x to 10. We then have a unconditional jump to label 2. We print x and check if it's equal to 10, and it should be printing 10 at this point. So after it passes the check, it will go back up to label 1, which is defined on line 8. So we will see it go back up. It jumps to label 1 and it reassigns x to 15, and then we output. So I want you to take a moment to ponder. Take a few minutes to try to think about a way that we could use a Goto statement and label to create a loop. So if you need a specific challenge, start with an integer variable x initialized to the value 10 and only using a printf function call with a Goto statement and a label. Output the values from 10 to 0. So you're making a looping statement inside of Gotos and labels. So here is an example of looping. We have the variable x, which is equal to 10. And what we're doing is we declare a Goto statement, which is at line 12, which jumps to our label, which is defined at line 7. So initially when this program runs, we're going to see the assignment of the variable x to 10. We're going to print out 10, and then we're going to check to make sure that x is greater than 0. So if it's greater than 0, we're going to go ahead and decrement x, and then we're going to jump back up to the top portion of the loop, and we're going to continue that over and over until we hit 0. And if we look at our output on the right, this is exactly what it does. So this is one way to achieve a loop using Goto and labels. So brief review, the C language provides the Goto statement and a label, which can be thought of as a unconditional jump. So unconditional jump means that a Boolean expression doesn't need to be evaluated in order to jump to a piece of code. So unlike a switch statement or a loop or something along those lines, it can just jump around to specific pieces of code. Oftentimes people will refer to the code that is written like this as spaghetti code, but in certain scenarios they become easier to reason about rather than building crazier constructs that make the program more complicated just to avoid using labels. So again, loops can be created using goto statements and a label. All right, let's go ahead and start our live coding session with the goto and labels. So just going to do the typical setup here where we write our hello world program. Right, so again, typical program, just to make sure that all the tools and everything that we're using is working. So there we go. Now what we're going to do is we're just going to explore the ability to skip over blocks of code by using our goto and labels. So let's make an int variable x10. It's kind of like the example we did. We'll just have a skip label, something along these lines. And most people, when they write their labels, they like to write them at the furthest left, so that way you can kind of see where they are. So we're going to go ahead and skip. And what we're going to do is we're going to say x equals 100. We're going to print x here. And once we print x, let's make sure we add a new line. What we're going to do, we're going to say go to skip. So what we should see is the variable x gets declared and assigned. So a assignment with the declaration, and then we go to skip, which should print out 10 instead of 100. Whoops, so this should be x, and you may not see, a.out, and there we go. So it doesn't matter if there's a space here or not, we'll just recompile just so that way you see. It doesn't really matter, it will still skip over this. Now what we can do again is we can actually go back up and reprint this out by simply stating, you know, another goto statement where we say, let's say go to something like, let's just say R. Let's just make it R. Go to R. Right, so what's going to happen now is first 10 will print out, and then we'll go back up to R, and then we'll just fall through the rest of this, and it'll print out 100. So just like our other example. Okay, so the reason why it's doing this now is because this is a good point. We are now stuck in an infinite loop. So let's recompile and run this again. The reason why we're stuck in an infinite loop is because we are continuously going back up to R. And so we're continuing to print out 100, 100, 100. So what we want to do is say if x does not equal 100, we want to go to R. And there we go. So this is kind of an easy way to show how you can actually end up writing some code that can infinitely loop with goto statements as well. There's really not a whole lot special. Sometimes people use this in like a particular loop condition. So if you have like a lot of looping things, for instance, let's just write a, I don't know, let's say 100. We'll write another loop inside of here. So what we can do is maybe for some reason when if j is equal to, I don't know, 10, then maybe we go to, I don't know, maybe we go to end, you know, like, so this is typically where you will see things like this. And just to remain consistent, I like to use the curly braces personally. So, you know, maybe you have tons of nested loops or something like that. I mean, we could even get crazier and add another one. But let's say and I equals, I don't know, let's say 50. So end is here. Printf. Actually, let's do this. Before we go to end, we will print out I and j, just to make sure. So we have I, j. We're going to go to end, and it should be here. And we'll just printf end. Okay, let's compile, make sure we're good. Run. Okay, right. So this is exactly what would happen. Now, in order to give us some more feedback, we can just do this. Actually, better yet, let's just add this guy here. Right. Okay, so you can see that it loops over a bunch of times, and then when it hits a particular condition, it can actually jump out. Now, you may be asking yourself, what's the difference between doing something like this and what's the difference between doing something like a break statement? Well, typically what you'll find is that maybe for some reason it will like jump back out into the outer loop, or maybe it will reinitialize some variable here and it will actually jump back to the beginning or something. But that's usually the use case that you will find some things like loops, like these labels being used. So again, most people will refer to code like this as spaghetti code, but really underneath the way this works, loops work in general, is by using something very similar. So you can think of it as something called a jump table. So hopefully this was fairly intuitive and you understand what's going on. If not, no big deal. Typically you won't actually run into a lot of code that shows Goto and labels.